for a one sample test. Now, in problem 7, we need the t-statistic for a two sample test. So a two sample test. Again, this is given to us right here. It's the same formula. The test statistic equals, I'm not sure why it's coming up so light, but the test statistic is the statistic minus the parameter over standard deviation of the statistic. It's slightly different for two samples. So for two sample, all you do is this. You say t equals x bar 1 minus x bar 2, all divided by, and instead of putting s, here's the standard deviation right here. Difference of sample means, here it is right here. So it is square root of standard deviation of 1 over n1 plus standard deviation of 2 over n2. Right here. This is a pain to do by hand. I mean, imagine trying to plug in every single thing here. First, you got to plug in x bar 1, which is the average on A. Then you got to plug in x bar 2, the average on B. Standard deviation of A. Sample size of A. Standard deviation of B. Sample size of B. It's so much. It gets very messy. Don't worry about that. Literally, it's right here on the calculator. I would write in what you're going to do. So you're going to say x bar 1 is 24.8 minus x bar 2, so for B is 22.9, divided by square root. Standard deviation of A was 3.1 over 43 dogs, plus standard deviation of B was 3.3 over 41 dogs. And that's equal to, don't plug this mess into your calculator. Don't plug this mess in. Just do the test right here. And here's the test we did. And there's the t-value right there. 2.716. 2.7167. That's it. On the 8384, here it is, you guys can't see that, 2.7167. Let the calculator do the work. Show the AP test grader you know the formula, show you know how to plug in, and then let the calculator do the work. Don't sit there plugging this in manually to your calculator. It's a waste of time. Alright, and now I want to actually take the final step and put everything together. This is what we have been building up to for the entire past 3 days. And now we're going to actually carry out the test. So I'm going to do this for problems 2 and 7. On your homework, you won't do it for all of them. I'll tell you which ones to do. So here we go. Let me start with number 2. So with number 2, the rule is, for the test, you reject the null hypothesis if the t-statistic is greater than the critical value and the p-value is less than the significance level. That's it, folks. We reject H0 if the t-statistic is greater than the critical value and the p-value is less than the significance level. So for number 2, we just found that the t-stat was 1.65339, and we found that the p-value was 0.0519. So we now want to compare this on these two levels. So 0.0519 is bigger than 0.05, which is the significance level. The significance level is 0.05. So that fails. And the t-statistic is 1.65, which yesterday we calculated the t-statistic for, yesterday we calculated the critical value for this mic problem, and the critical value we got was 1.671. This is less than 1.671. This was the critical value we got yesterday. This is the significance level the problem gave us. This is the p-value we got today, and this is the t-statistic I just got. We fail on both. Therefore, we conclude, and you must write the statement, we fail to reject the null hypothesis, and we conclude, that's a we by the way, we conclude that Mike's free throw percentage is equal to, the null hypothesis was what? Equal to 0.5. This is it, folks. This is what we've been building up to. This is what statisticians do for a living. They conduct these tests to see if things have an effect. Let me finish up for the dog problem, and then we will be done with this video. So on the dog problem, number 7. Remind ourselves, H naught was that alpha equals beta, that program A equals program B. The alternative hypothesis is that they're not equal. The p-value we got was 0.00805, which is absolutely less than 0.05. But a lot of people are going to make this mistake. Because this is a two-sided test, we don't use 0.05, we use 0.025. Alpha over 2, because it's a two-sided test. Remember, two-sided does not equal. So A could be bigger than B, which is way over here on the right, or B could be bigger than A, way over here on the left. Doesn't matter. Even if we use 0.025, we have 0.00805 is still less than 0.025, so that's good. The t-stat we got was, what was that t-stat that we got? I'm trying to find it on my papers here, a lot of paperwork, was 2.7167. The critical value we got yesterday was, what was the critical value we got yesterday? 2.021. 2.7167 is greater than 2.021, so we're good on that. So we passed both tests. Remember, the tests are, is the t-statistic bigger than the critical value? Yup. Is the p-value less than the significance level? Yup. Thus, or therefore, we conclude, don't say conclude, therefore we reject the null hypothesis and conclude that program A and B have different average hours. That is it, folks. That's what we've been building up for 3 days. That's what we're going to pick up on Monday. On Monday we'll carry out this whole process for 1 or 2 problems. Have a great weekend, folks, and I look forward to seeing you all back on Monday.